All right, hi everyone, welcome back. We're going to do another specific type of LP problem today called a binary example. We're going to use it to make an investment decision. This is mildly amazing. I love this because you can get decision making down to a mathematical formula. You can let solver make decisions for you. I think most people know this, but just in case not, binary variables means 0 or 1. A lot of people have heard this with binary numbers, but binary means 0 or 1. For decision analysis, how we're going to use a spreadsheet to make decisions, for us, 0 is going to correspond to a no. A 1 is going to correspond to a yes. Now, there are lots of decisions that are binary. Should I hire someone? Should I not? Should I approve this project? Should I not? There are also lots of decisions that are not binary, where the answer might be sometimes, or maybe, or a percentage. So not every decision is going to be modeled by a binary decision variable, but sometimes you can. Here, read the problem if you haven't done so. We're going to decide if we should invest by some, all, or none of these 7 investment opportunities. This is a yes-no decision. Do I buy the block of shares for Texas Transoil at this cost? Yes or no? Do I buy the block of shares for BP at this cost? Yes or no? We're not asking how much money do I put towards it. We're not asking what percentage of an investment do I put towards it. This is just yes or no. And when you have a problem like this, then you can model it and solve it, optimizing on something using solver. So you can get decisions down to mathematical equations. All right, read the problem if you haven't done so already. And let's think about how we're going to model this. This particular example is going to be a yes-no on finding the right investment to maximize the return. Now, just so you know what we're looking at here, we have a bunch of constraints up here by the client. That's fine. We have 7 stocks that can be bought in block. Now, watch the units here. These are in thousands. So one block is 480,000. We'll leave the number small for Excel, but then when we write our summary sentence, we have to watch our units. The return here in thousands of dollars, the expected annual return is all positive, and we have up to $3 million for investing. So in a perfect world, if I had the choice where I know everything is going to have a positive return, obviously I pick the highest one here, Houston Drilling, and I look at it and say, well, this is going to be the highest return. But I have these constraints that are just going to prevent me from buying only one thing. What are the decisions that I have to make? I have to decide yes or no to these 7 stocks. That is 7 separate decisions. So our variables here, which are binary now, and I'll just call them X1, X2. I don't have a good name for it. It's like yes or no, do I buy it? I don't want to list out all 7 stocks. So X1, X2, X3, X4, X5, X6, and X7. And I'll shrink the columns a little bit as well, just so we have nicer formatting. Maybe I'll move this over here. And it's important to realize what this represents. This is the first time in any problem that we've done, we're not representing the variables with a dollar amount. We're not representing the variables with how many bags of coffee beans or something. It's a yes or a no. It's almost like text. We're going to represent them, of course, with numbers, 0 or 1, because, of course, Excel doesn't like text, but we have 7 variables. We've seen problems with 7 variables. The number 7 shouldn't be too scary. This isn't the thing that should concern us. It's the use of the variables, the fact that it's going to be 0 or 1 to decide, should I buy the stock or should I not? You can imagine, just like last time when we had mixed integer problems, so some variables were binary, some were not. This is a particular type of integer, but instead of any integer, it's 0 or 1. It's a binary integer problem. Now, think about what I want to do here. I want to optimize my return. So my objective as a financial investment firm would be to maximize what? Maximize the return on this. So this would be my gray cell. This one here I might need to make a little bigger. Instead of me expanding the column out, what I'll do is I'll merge it. And let's think about each investment. What does it return? So this is where, again, the units are in thousands, so maybe I'll put my units here on the side, just to remind myself that the units are thousands. And if I buy the first stock, my expected return, of course, is 50. The second stock, its return is 80, 90, 120, 110, 40, and 75. So here's how this is going to work. I'm going to ask Solver to find me the best results here. And Solver is going to come back with a bunch of zeros and a bunch of ones. So let's just pick ones across the. It can't give me any other number. So I'll do 1, 1, 1, 1, maybe a 0. 1 means yes, purchase the block of shares for Texas Oil. A 1 in X2 means yes, purchase also the block of shares. This is yes or no. It's either buy it or don't buy it. Not put this much money towards it, but yes or no. If a 0 comes back, then that answer is no. Don't buy this one. So buy it, don't buy it. Yes or no. As a reminder, 0 is no and 1 is yes. Now, what is my expected return? How can I do a formulation on this? If I buy the block of shares, if I buy the Trans Texas Oil block for $480, that'll be my cost. That'll be a constraint that I'll build into the $3 million for investing. Then my return is 50. So these are my returns in thousands of dollars. Just remind myself those units over there. My return for this block of shares is 50. My return for this block of shares is 80. What's nice about this is you multiply this together, you still get 50. If you multiply the 1 and the 80, you still get 80. When you multiply the 0 and the 75, 0 being no cancels the return. So if you do a sum product, which is exactly what we're going to do, again, this is still an LP program, on the decision variables, all 7 of them, comma, their expected returns, line up the 2 blocks of cells, close the parentheses and hit enter, and I'll show that formula here so you have it. You can see that the sum product is doing exactly what you want. When there's a 1, it adds the expected return, and when there's a 0, it adds 0 times 75, which is saying nothing. 0 times 75 is 0. If I turn all of these off, if the solver comes back, it won't do this, of course, but it'll say, what if you turn all of them off? Then the return is 0. 0 times 50 plus 0 times 80 plus 0 times 90 is always going to give you 0. Play around with this, and again, dummy numbers here are key. If I did every other one, you can check 50 plus 90 plus 110 plus 75 is exactly 325. This will be in dollars, and this will be in thousands of dollars. So I have to watch my units here. But it's doing exactly what you want. It's adding up the ones that are turned on, and it's turning off the ones that are turned off. This is the power of 0 and 1 and how you can use this in decisions. Now, I have these 1, 2, 3, 4 constraints that are on here. So let's start to build our constraint table. I'll move the text over a little bit. As always, even though we have 7 decision variables, we're going to go 1, 2, 3 over. So I need columns I, J, and K here. And we're going to put some constraints down. I have about 4. We'll build a nice table. We're still going to use our left-hand side, our sign, and our right-hand side. Now let's think about what this means in terms of the constraints. The first one says at least 2 Texas oil firms must be in the portfolio. Someone loves Texas oil. So Texas oil, which ones are my Texas oil firms here? You may not be as familiar with some of the cities in Texas, but just in case you are not, the Texas one here is, well, obviously the Trans Texas Oil is a Texas firm. Houston is a big city in Texas. So I'll copy that as well just to remind you. And then there's one other called Texas Petroleum. These are all fake, of course, but Texas nonetheless. So the first one, the fourth one, and the fifth one are all your firms from Texas. And the client has demanded that at least 2 of them must be in the portfolio. So let's label this constraint, at least 2 Texas. Which ones we say those were? It was the first one, the fourth one, and the fifth one. So I'm using a 1 here. Again, 1 means turn it on, yes, to purchasing that one. And now how do I build this in as a constraint? If you want, this is a good place to pause the video and think about how you would do that. What's the sign going to be? I need at least 2. At least 2. This is the tricky one. At least is the one that is greater than or equal to. It's a little bit counterintuitive. So greater than or equal to 2. And the left-hand side is no change. It's still our good old sum product. What is it of? The variable cells, comma, and then these numbers here in the constraint table. So I'll stay on that so you can see the formula for it. It's the same formula we've always done, but realize what's going on here. It's counting how many of these firms there are. This 2 is coming from what? 1 times 1, so X1 is on, Trans Texas is on, X4 is off, so that's 0. It's contributing 0 to the sum, and then one of these is on again. So I put a 1 in here to almost count it. We've seen this before when you want to count what the variable is, but then it becomes a 1. And if I just happen to have some combination where, let's say the Texas ones are off, so X1, X4, and X5 are off, this will be 1 plus 0 plus 0. That's what's happening here when I'm adding up these numbers, and I get that the left-hand side is a 1, and this combination would not be in my feasible region. It would fail the constraint, and this would never be returned as a solution by solver. So that's the first one. If you want, pause the video and see if you can get 2, 3, and 4 for your constraints as we go. All right, constraint number 2, no more than 1 investment can be made in foreign oil. So no more than 1 foreign. So now we have to think of ourselves, which ones are foreign oils? There's 2 of them here, British Petroleum and Dutch Shells. These are your 2 foreign oils. So we'll keep track of if X2 and X3 variables are turned on. And it says no more than 1. So my left-hand side, let's actually put the dollar signs in before I forget. So we'll put $B, $8, $H, $8. You can just drag this formula down. No more than, that is less than or equal, and it says 1. So no more than good old 1. Great. Third constraint, one of the two California stocks must be purchased. So you can have one, but not both. So California constraint here. Which ones are my California? Again, if you know some cities in California, great. If you don't, I'll tell you here. The California would be San Diego. It's a wonderful city in California. California Petro, obviously that's California as well. So I have X6 or X7 that I really have to worry about. So let's think about this for a second. How can I say one of the two stocks must be purchased? So I definitely need to keep track of X6 and X7. My left-hand side formula is not going to change. That just gets dragged down. My right-hand side says one of two stocks must be purchased. So I need to make sure, so what's happening right now? If I sum product this, I get 0 times 1, which is 0. So this is like counting how many are turned on. What is the thing that goes in sign here? If I do less than or equal, then having no California stocks would be okay. If I do greater than or equal, then having 2 would be okay, and that's a problem as well. I'm only allowed 1. So what's my sign here? Equals. Equals. If you remember in the drop-down list for solver, equals is a choice. Here's one where we actually want equals. I just want this to equal 1. That'll be okay. Notice if I turn both on, then the sum turns into a 2, and that's not allowed, so this won't pass. If I turn both off, then I get a 0 back, and no, that's no good because I need one of the two. So really what I'm allowed for is just one of these two. So equal will be my sign here. That's a good one. That's a new one. And then last but not least, of course, this is my budget, and it says up to $3 million for investing to purchase a single block per the table below. So if I buy the first one, what's the cost? And now here's where I use these numbers in the table. If I buy X1, what's my budget? Budget is good old-fashioned less than or equal. And now you got to be careful here. It's 3 million, but all my numbers are in thousands. So you have to be very careful here. I want to put 3000. I don't want the extra 3 because that's included in the units all over the place. So I want 3000 here. So watch out for that. That's a little tricky. That's you could really you could have everything perfect and mess that up with the budget. Anyway, so if I buy the first one, what's it going to cost me? That's going to cost me $480. If I buy the second one, what's that going to cost me? $540. And you can work your way across the table. So $680, just copy it correctly. $1,000. $700, $510, and $900. And now when I do sum product, for all the ones that are turned on, it will sum their cost to my total. And this cost should be under 3,000 or 3 million. All right, I think everything is good to go. Let's go ahead, just give it one quick check. Make sure you agree. Data, solver, the box pops up. Let's set our objective. That is the gray cell. For me, it's in sort of the merged B12. I hope it works with the merge. We'll find out. I want to maximize this cell. This is my return. My variable cells are the 7 variable cells for me in row 8, subject to the following constraint. I want to add a couple constraints here. Now, nothing is batchable. I can't do it, so I just have to be careful here. Let's do the first one that for the Texas constraint. So the first one is greater than or equal to 2. Let's add another one. This is my no more than 1 foreign. My left-hand side is less than or equal to 1. Let's add another one. My California constraint is equal to 1. Use of equal there. And then last but not least is my budget. So I want this number to be less than or equal to this number. Left-hand side less than or equal to the right-hand side. And now here's the new one. Now I was going to hit solver and solve it, but let's just go right to it. Let's do one more and add. Just like before, when I had to tell solver that the variables had to be integers, remember binary is a specific type of integer problem. I still have to tell solver that all 7 decision variables, at least all 7 in this case, you can imagine cases where some of them are binary, some are not, have to be binary. And that's right here. It's the drop down after integer. It's the next one on the list. It is a binary decision variable. As usual, it populates the binary constraint. You hit OK. And it gives you the box back. Just make sure you agree. Objective, max, variable cells. There's the binary constraint. Select the box to make unconstrained variables non-negative. Select simplex LP, and then you can hit solve. Solver found an integer solution. Say thank you, solver, and come back and hit OK. And here it is. So solver is coming back and say, I want you to purchase X3, which is your Dutch shell, X4, Houston drilling, X5, and X6. And my return here is $360,000. So convince yourself that this purchase of X3 through X6, of the 3rd through 6th option, actually meets all of them. Do I have at least 2 Texas oil firms? Sure do. I have Houston Drilling, and Texas Petroleum. Do I have no more than one investment in foreign oil? That's right. I just have Dutch. I don't have British. Do I have one of the two Californias purchased? Yes, I do. I have X6, which is San Diego, but not X7. And lastly, did I stay under budget? Turns out my budget here is $2,890, which is under my restriction of $3,000. So that would be my summary sentence. So the only thing that I just would caution about in the summary sentence, you kind of have this here. So you purchase, and you can list these out. I'll just say X3 through X7 in the interest of time for a return of, now just be careful here, it's $360. It's not dollars, $360, it's $1,000. So just watch the units. And that is the maximum return. Again, play around with this if you want. Turn these zeros and ones and flip around. See if you can beat Solver. You won't be able to. 360 is the absolute max where all the constraints are satisfied. You might be able to find better answers, but you're going to break some of these constraints, which means you lost a $3 million client. That's never a good thing. This binary analysis, it takes making decisions down to a spreadsheet, which is extremely, extremely powerful. So go over this one. Make sure you understand it. Great job on this one. We'll see you next time.